Run a little harder. All right. Example 16. Example 16. It says a roller coaster uses a 6 horsepower motor to raise the train There's my attempt to draw a roller coaster with its train and the well, the front car's got a little more aerodynamic. There you go. Okay. So there's my roller coaster with the motor, right? All right. Attempting to draw it. So we want to know how tall this hill is. Right? The time is 3 minutes. Did I use 3 in Akira? No, what do I do?
It's
180. Good. And multiply 3 by 60 because we can be in seconds. Good. And we know the roller coaster has a mass of 2,000 kilograms. This is why doodlers like physics, because we can draw pictures of random stuff. Right? Okay. Any questions at 2,000 pounds small? Okay. Any questions? How do we do it? Well, power equals work over time, right, Kevin? Oh, now work. Power equals work over time. What's another equation for work? Force divided by time, right? Or force times time. Man, I'm all over the place today. Work is also the product of force and time, right? Or force and displacement. Goodness. So work is force and displacement. So power equals force times displacement divided by time, right? Right? What's this D? Displacement. It's the amount of displacement that's parallel to the force, right? Right? So, what force is the roller coaster fighting? Gravity. So gravity points down, so that means the roller coaster chain's force has to point up. Now I know that force is along an incline, and we could figure that out if we need to. Okay, we can figure that out if we need to, but they don't ask for that. They just want to know how tall the roller coaster hill is, right? So this is the part of the chain's force that's vertical, right? Does that make sense? So we need to figure out that D, right? Okay. What's the relationship between the force of the chain and the force of gravity? They're equal. So that means this force is really mass times gravity. Mass times 9.8, right? So power equals mass times 9.8 times displacement over time. Right? So what's the last thing we have to do before we can start plugging things in? Into watts, good. So we know 1 horsepower equals 746 watts, right? So I can turn my horsepower into watts by multiplying by 746. Your horsepower will cancel. So how many watts is that? A couple?
4,470.
What? What was it?
4,470.
See, that joke's funny as long as you have good timing on it. If you do it all the time, it sounds fun. Right? No? Okay. It's all about time. All right. So that's our power, right? Okay. So let's plug in what we know so we can solve. So we know 4,476 equals 2,000 times 9.8 times the displacement, which is also our height, divided by 180. Right? What's 2,000 times 9.8 divided by 180? So we can call it 109? Is that okay? Yeah? So now we do that 109. Divide. So 4476 divided by 109 equals 41. 41.1. Does that make sense? Yeah. 41.1, not 411. Sorry about that. Any questions?